SolidWorks Simulation, Lecture 8, Part 1, Steady State Thermal Analysis. For the preparation step 1, load the software. And this is the software, SolidWorks Simulation. The preparation step 2, load the toolbar. This is a toolbar. And we can draw a 3D model and open a study, which is thermal analysis. In thermal analysis, there are two types. The first type is steady state. The second type is transient. And for steady state, the time goes to infinity and the system is in thermal equilibrium and the temperature no longer changes. So we'll run steady state first. And for the third preparation step, we will organize the toolbar, customize, commands, simulation. And we will eliminate these solid tools and increase thermal tools. I'll use convection and heat power. I'm not going to use heat flux because heat flux is the heat power divided by area, and the temperature is for transient study. So now we have performed the third preparation step. So there are 3 steps to prepare for the analysis. The first one is to load the software, the second is to load the toolbar, and the third is to organize the toolbar to facilitate your analysis. So we have performed the first step already, which is drawing a 3D model of the geometry and then open a case. And the second step is to define the material. And the general material for heat sink is aluminum alloy. And I'll choose aluminum 6061. Aluminum 6061. I'll choose this material for the heat sink. And the mesh, I'll define a default mesh, and I'll hide the mesh. For step 4, I'll apply the heat source first, and the heat source should be 28 watts, which is the power of the CPU I look up from the Google. So this is the heating power. And then for the boundary condition, we have the convection of air, the stagnant air. We'll choose all surfaces except for the bottom surface, which is in contact with the heat source. And the convection coefficient for stagnant air. Stagnant air means the air is in stagnant condition, or the still air. The velocity of the air is 0. And for the temperature, I'll switch back to metric and give it 25 degrees C, or it is 298 degree K. So this is a convection coefficient for stagnant air, and this is ambient temperature, the room temperature. And then we apply the load, which is the heating power of 28 watts, and the convection condition to be the boundary condition. I'll make the icons smaller. Okay, so step 5 will be the solution. And this is the solution for steady state thermal analysis. First of all, we will change the unit from K to Celsius, and then the format of the numbers into a floating point and 2 digits under decimal, which is enough. And the highest temperature is 101 degrees Celsius. And then we can probe for the temperature. Probe here. And the temperature will be 96.29 degrees Celsius. And we can also probe for other values. But I'll stress a point here that this is the temperature where the time goes to infinity and the system reaches a thermal equilibrium, and the temperature here will be 96.3 Celsius. And we'll perform transient analysis to see how this temperature rise from 25 degrees C to 96.3 in the next lecture.